Assalamu alaikum, how are you all? I hope all of you are well. I'm Rizwana Mukhtar, lecturer, Department of Physics, Milestone College. I welcome all of you in the another virtual class of physics. In my today's class, I am going to solve two creative questions. I hope this class will help you for your better study at home. So let's start our today's class. Dear students, our today's first CQ question is from Slate Board 2019 and the question is, there are 400 chickens in a poultry farm. The present intensity of sound in the poultry farm is 3.2 into 10 inverse 4 watt per meter square. The owner of the farm increases the number of chickens up to 2400. Here, the standard intensity of sound is also given. The value is 10 inverse 12 watt per meter square. Now, question C is, determine what was the intensity level in bale of the poultry farm. That is, we need to calculate the value of beta in bale unit. So, here the given informations for question C are intensity of sound, which is denoted by I, and the value of I is given here 3.2 into 10 inverse 4. Inverse 4 watt per meter square. Now the standard intensity of sound. Standard intensity, that is denoted by I naught, and the value of standard intensity is 10 inverse 12 watt per meter square, and we have to calculate the intensity level. And you know that intensity level is denoted by beta. So, beta is equal to what? Now, we know the formula to calculate the intensity level, that is beta is equal to
log I by I naught. Here we usually use 10 log I by I naught, but as here we have to calculate the intensity in bale unit, so we used here only log I by I naught. Now log 10 and the value of I is 3.2 into 10 inverse 4 and the value of I naught is 10 inverse 12. After calculating it, you will get the answer 8.505 bale. So this is the answer of question number C.
now question D, and the question is, what kind of problem may occur in the farm due to increase the number of chicken in the farm? Here you can see that from the stem that the owner of the farm increases the number of chicken from 400 to 2400. As the number of chicken is increased, that means there must be the intensity of sound level increase, and we have to calculate the increased intensity level of sound. So, for question D, we can write that if you want to calculate the intensity level for 2400 chicken, so firstly we have to know that the intensity of 2400 chickens. Here from the stem you can see that the intensity for 400 chicken is given. So we can easily calculate the intensity for 2400 chicken by using unitary method. So we can write that for
For 400 chicken, intensity is 3.2 into 10 inverse 4. So for one chicken, intensity 3.2 into 10 inverse 4 divided by 400. Now for 2400 chicken, intensity 3.2 into 10 inverse 4 divided by 400 into 2400. So after calculating it, you will get the value 1.92 into 10 to the power minus 3 watt per meter square. And this is the value for 2400 chicken. So we can consider it as I2. Now we know that beta is equal to 10 log I by I naught. As we are calculating here the intensity for 2400 chicken, so we can consider I as I2. So 10 log I2 means 1.92 into 10 inverse 3 divided by I naught. The value of I naught is 10 inverse 12. After calculating it, you will get the value of beta 2 is 92.83 decibel. Now for 400 chicken, we get the value of beta is 8.505 bel or 85.05 decibel. So we can consider that the increase of intensity level, that is del beta, is beta 2 minus beta 1. The value of beta 2 is 92.83 and beta 1 85.05. So you will get the result of del beta is 7.78 decibel. And
our second creative question is from Joshua Board 2017, and the question is equation of two sound wave in air is given below. Here y1 is 0.25 into 10 inverse 2 sine 16.35 into 105.1 pi t minus x, and the equation y2 is 0.25 into 10 inverse 2 sine 110 into 15.764 pi t minus 0.15 x. The density of air is given here 1.29 kg per meter cube. Now question C is, if both waves are sounded together, determine the number of beats it creates. So you know that the number of beat means the difference of frequency of two sound waves having same amplitude. From the equation you can see that both equations the amplitude is same. So if these two sound waves sounded together, then there is a possibility of creating beat. So we need to calculate the value of n. To calculate the value of n, we have to know the value of frequency of these two sound waves. Start to calculate question C. Now, here y1 is 0.25 into 10 inverse 2 sine 16.35 into 105.1 pi t minus x. I am going to multiply 16.35 with this quantity. So, the equation y1 will be 0.25 into 10 to the power minus 2 into sine. Now, if we multiply 16.35 with 105.1, then the result will be 1718.385 pi t minus 16.35 x. Now, mark it as equation 1. Now, I am going to make the similar change with equation 2, that is y2 is given here 0.25 into 10 inverse 2 into sine 110 into 15.764 pi t minus 0.15 x. Now I am going to multiply 110 with these two quantities. So our result will be into sine 734.04 pi t minus 16.5 x. If you multiply 110 with 0.15, then you will get 16.5. Now mark it as equation 2. Now know that the equation of progressive wave is, we know equation of progressive wave is y is equal to a sine twice pi by lambda into Vt minus x. Now I am making a little change in this equation, as you can see that in equation 1 and equation 2 sine, there is nothing multiply with sine. So I am going to make this equation similar as equation 1 and 2. So if I write that a sine twice pi Vt by lambda minus twice by x by lambda and make it as equation 3. Dear students, now we can compare the equation 3 with equation 1 and equation 2. So firstly, I am going to compare the equation 3 with equation 1 so that I will get the value of f1. After that, by comparing equation 3 and equation 2, we will get the value of f2.
Now for equation 1 and 3, you can see that twice by Vt by lambda is equal to 1718.385 pi t. So we can write that twice by Vt by lambda is equal to 1718.385 pi t. Now t and pi cancel from both sides. So we can, here you can see that V by lambda means frequency. So we can write f is equal to 1718.385 divided by 2, and the value of f1 will be 859.19 Hertz. Now I am doing the same thing with equation 3 and 2. So we can write that twice pi Vt by lambda is equal to 1734.04 pi t. Now pi t and pi t cancel from both sides. So here f2 will be 1734.04 divided by 2, and the value of f2 will be 867.02 Hertz. Now we can easily calculate the number of beats it creates when both sound waves are sounded together. So n is equal to f2 minus f1, that is 867.02 minus 859.19, and the result is 7.822 per second. This is the answer of question C.
Question D. The question is, with intensity level, explain if the sound made by second wave is suitable for hospitals. That means we need to calculate the value of beta, and you know that if the intensity level of sound is in between 50 to 60 decibel, then that sound will be suitable for everyone. But if the intensity level cross 60 decibel, then that sound will be irritating for us. So we have to calculate the value of beta, and we find that the value of beta is more than 60 decibel, then that sound will be not suitable for the hospital. So here calculate the beta, we know that we need to know the value of I, and you can see that they did not give the value of I directly. So firstly we have to calculate the value of I, or intensity of sound. Write that equation as 0.25 into 10 to the power minus 2 into sine. Now if you multiply 110 with these two quantities, then the result will be 34.04 pi t minus 16.5 x. This is the equation 1. That the equation of progressive wave y is equal to a sine twice pi by lambda into Vt minus x, or y is equal to a sine twice by Vt by lambda minus twice by x by lambda, and make as equation 2. Now by comparing equation 1 and 2, we can easily calculate the frequency, wavelength, velocity and amplitude, which are needed for calculating intensity of sound. So, for 1 and 2, we can write that twice pi x by lambda is equal to 16.5. Twice pi x by lambda is equal to 16.5 x, or lambda is equal to, if you cross multiply it, then we will get that by 16.5. Value of lambda will be 0.38 meter. And from C, we have already get the value of frequency, which is 867.02 Hertz. So, we know V is equal to F lambda. F means 867.02 into lambda means 0.38. So, you will get the velocity of sound for equation 2 is 330.16 meter per second. Dear students, you know that here A means amplitude and the value of amplitude is A is 0.25 into 10 inverse 2 meter. We know that to calculate the intensity of sound, the formula is, we know I is equal to twice pi square f square a square rho v. Now we know all the informations. So I am going to put all the values here. Now I 2 into pi means 3.14 whole square into f. The value of f is 867.02. 867.02 whole square. Now the value of A is 0.25 into 10 inverse 2 into 10 inverse 2 whole square. Now rho means the density, and density of air is given here 1.29. Now V means the velocity of sound, and the velocity of sound is 330.16. 330.16. So after calculating it, you will get the value of intensity is 0.95 into 10 to the power 4 watt per meter square. Now we can easily calculate the intensity level or beta. Now beta is equal to 10 log 10 I by I naught. Value of I is 3.95 into 10 to the power 4, and the value of I naught, that is the standard intensity, is 10 inverse 12. So after calculating it, you will get the value of intensity level, or the value of beta is 165.97 decibel. So we get the value of intensity level for second wave is 165.97 decibel. You know that 50 to 60 decibel is suitable sound level, and here we get the value is 165.97, which is not suitable for hospital, not even for normal persons. Say that this sound level is not suitable for the patients. So that's all for today. Thank you for your patience hearing, and best of luck for your upcoming exam.